Hello. So in this video I'm going to take some simpler identities and just work them out, and I'm going to think out loud so that you can hear what's going on in my mind and how I kind of get to the place I get to. Now when I go to verify identities, first of all I use only this toolbox. Right, these are the only ones that I can use and never have to explain why I did what I did. I can use them. Okay? So if you want to pause and just like look at these, that's fine. All right, and then here's some suggestions that a lot of books pretty much give you. I wish I could say to you that there's a recipe that if you just follow this recipe, you'll be able to get every single identity verified. But it's sort of trial and error, and you really do have to practice quite a bit. Okay, so if you can pause the video, you can read those. And then I'm going to start by picking a few simple ones and just go ahead and verifying. All right, so example 1. Tangent of theta over secant of theta is the same as sine of theta. So thinking out loud for you, when I look at these, I like to try working with the more complicated side. In this case, this is more complicated because you've got a division, and also these could be broken down or expressed in terms of sine and cosine. So I've got something to work with. So here I'm going to express tangent as sine over cosine, and that's the numerator. Now what I do is I make a really long bar so that I know, oh yeah, that's the numerator. And then here in the denominator, I'm going to go ahead and express secant 1 over cosine of theta. Right? Now notice I work with one side only. I don't touch this. I just keep dragging the equal sign with me. But now I have a fraction over a fraction, and when you have a fraction over a fraction, you can simplify it. So I'm going to take the denominator, flip it, right? Take the reciprocal and multiply. So I'm going to have sine over cosine is in the numerator. And now, times. And now when I flip and multiply, I'm going to have cosine theta over 1. Right? Now, since this is multiplied, the cosines will cancel out, and I'll just have sine divided by 1, which is sine. So I've gone ahead and verified this identity. Okay. Let's take a look at another one. So example 2. Tangent squared of theta plus 1 over secant theta is equal to secant theta. Okay, so here, again, this side looks more complicated to me than this side. Looks a little odd that I already have secants on both sides, but hey, I gotta just start working it out. Now, so I'm gonna go ahead and again break these down into sine and cosines. So tangent is sine squared theta, because it's squared, over cosine squared theta, plus 1 over secant theta, which is 1 over cosine theta. Okay. Now, I don't want to go ahead and flip and multiply because I really need to get this to be all one numerator, and so I want to go ahead and do what it's begging me to do, which is to add. But to add these, since this is a fraction, I need to get a common denominator, and the denominator is cosine squared. So I'm going to express 1 as cosine squared over cosine squared. So here I'll have sine squared theta over cosine squared theta plus cosine squared theta over cosine squared theta all over 1 over cosine theta. Okay, and notice I just keep writing that equal sign, bringing it down. Now I have the same denominator, so I can put these two in the numerator and basically write them as added. Now you might already notice that it's sine squared plus cosine squared, which is 1, but I'll go ahead and write it. So it's all of that over cosine squared theta, and then that is all over 1 over cosine theta. Okay. But for those of you who recognize it, sine squared plus cosine squared, one of the most fundamental identities, that is really just 1, right? So let me write that over here. 1 over, now its denominator is cosine squared, so I'll say cosine squared here. Now I have this big fraction bar, right? This is the other fraction. And then 1 over cosine. 1 over cosine. And remember, this is supposed to be equaling to secant theta, so I'll just write that here. So now this is looking a lot better. Now I have a fraction over a fraction. Again, I'm going to take the denominator make a reciprocal of it and multiply it to the numerator, so what we call flip and multiply. So 1 over cosine squared theta times cosine theta over 1, right? But remember, this cosine squared is really this. 1 over cosine theta times, again, cosine theta, right? Cosine squared. And then here, times this, cosine theta over 1. So one of these cancels out, and I'm left with just 1 over cosine theta, and that is secant theta. Okay. All right, I'll do one more example so that this video doesn't get too long. I'm trying to stay kind of on the simpler side. Oh, let's see here. Let's take a look at 1 minus sine squared beta over cosine beta equals cosine beta. All right, so that looks kind of similar. I know that 1 minus sine squared is cosine squared. So from my toolbox that I kind of remembered, right? Another form of sine squared plus cosine squared is 1 minus cosine squared when you just subtract sine squared from both sides. So instead of writing 1 minus cosine squared, I'm going to write sine squared. I'm sorry, instead of writing 1 minus sine squared, here, I'm going to write cosine squared because they're equal. So here I'm going to have cosine squared beta all over cosine beta. And you can see this is going to fall out really easily. So this is really cosine squared, right? You cancel the square here, so, but I'll write it out. Right, and this cancels out, and I'm left with cosine beta. All right, so I'll go ahead and finish off this video here and say thank you so much for listening, and I'll just provide more videos where they get a little bit more complicated, these verifying identities. Thank you so much for listening.